It's been a while, but it's finally time for another
Code.
Today I'm going to roast a chess game. Thank you, Adam, for sharing this code example. When I did these code roasts in the past, I often had to cut them up in 2 or even 3 different parts for them not to be way too long. I noticed that splitting videos up in parts doesn't work well on YouTube. The first part of a series often doesn't do well because quite a few of you wait until all the parts are out, which I totally understand. And then subsequent parts get lesser and lesser views because not everybody wants to watch the whole thing, which also makes sense. But this results in these videos performing really badly, which on YouTube means less people are going to find the content. And that's a pity. So here's an experiment. I am going to do a detailed code review because that's, I think, the part that you learn most from. But then instead of doing a full refactoring, which takes a lot of time, I'm going to zoom in on some of the things I mentioned in the review and show you an alternative way of setting it up. I don't know if that works. It's an experiment. Let me know in the comments what you think. For me, doing these code roasts has also helped me become more critical of my own code. I really encourage you to do more code reviews yourself. It's going to open your mind.
Open your mind.
I tell you, the B-roll on this channel is getting out of hand. Now, how do you become better at doing code reviews? You might want to check out my workshop on code diagnosis that teaches you a 3-factor framework that helps you focus on what's important. Go to ArjanCodes/diagnosis to get access for free. It's built on my own experience, reviewing code and trying to make the process more efficient and more effective. The workshop demonstrates the framework by looking at code from existing Python packages that are used in production. You're probably using one of these packages yourself right now. So, arjan.codes/diagnosis. The link is also in the description of this video. Now, let's take a look at that chess game. The chess game code is split out over 3 files. We have a GUI file, we have a logic file, and we have a pieces file. The GUI uses tkinter. That's what you see here. So it's a subclass of frame. So in the initializer, you create like the logic, so that links the logic and the GUI. And then we have a bunch of methods that start the game, create buttons, etc., etc. I won't go into detail into what these methods do exactly. I'll look into it later on in more detail. But in particular, there's a draw board method that clears the window and then goes through every row and column and draws the particular chess piece on the screen. That's what you see happening here. And then we have some methods to create a new game and an end screen when one of the players wins. Then we have a refresh method. This is called whenever you make a move with a chess piece, then you draw again the board. And then finally we create a TK object and a GUI. And then we set a title and we call main loop. The logic is a class, it's called chess logic, and it has an initializer that creates a board. It has some methods that are useful for filling the board with an initial set of values, like populate with fen, for example. This builds up the board using a fen string, which is a standard notation in chess. And then we have actually the most complicated part of this class, which is the move piece class, and that does all kinds of checks, like whether you're allowed to make that particular move, what kind of instance of different pieces so that it takes the right action, etc., etc. So this is pretty long. And finally, there are some helpful methods that move piece then uses, like finding the king on the board, checking whether it's mate or check, and a method to promote a certain piece to a queen. Then finally, we have the third file, which is pieces, and that has a piece abstract class that contains an initializer where we store the position, we set the color, and we have some status data like whether the piece has moved or not, what the last move was, etc., etc. It has a couple of abstract methods like getting the moves that this piece can make and moving the piece to an actual position. And then for each of the pieces, each of the chess pieces, we have a subclass. So this file is pretty long. It has like the empty piece, which is pretty trivial, of course. And then we have the pawn. So for each type of piece, we have a get move method that's going to be different. So you can see there's lots of logic here. And then I scroll down, we have a rook, for example, similar. Again, the overall for each of these pieces, actually, if you look at it, the get moves method is the most complicated. So for all the pieces, this is basically the class structure that you get. And then next to get moves, there is also a string representation of each piece, which returns a character depicting the particular type of chess piece. And this can be useful, for example, if you want to print the current configuration of the pieces in a text format. When I run this, the application entry point is GUI.ph. we get this window. Pretty basic, but now you can click on a piece and you can move it somewhere else, and then the other player's turn. So as a starting point, let's diagnose the code and see where the main issues are. So I'm going to start with GUI.py, the GUI. The first line is already an issue. From tkinter, we're importing everything. Generally, avoid these kinds of wildcard imports because you have no control over what is being imported. And also later on, when you want to refactor the code, it's really hard to figure out where a particular function or object or class is coming from. If you don't use wildcard imports, but you simply do an import tkinter, you could use an alias like import tkinter as tk, then it's still pretty short, but you at least know where the classes are coming from, because then here you would write tk.frame instead of just frame, which can come from anywhere. Also, the entry point of this application is GUI.py. To me, that doesn't make sense. I think there should be a main file, main.py, that contains the entry point, so that we always know that that's the one we should run when you look at the code. And now it's not clear. Maybe it was logic or pieces, we don't know. Now you can rename GUI.py to main.py and then the problem is fixed. Or you could leave the GUI class in GUI.py and create a separate main file that imports the GUI and then creates it. So basically what's here at the bottom, the if name equals main, that could move to the main file. And then also you should put this in a main function so that you're not polluting the global namespace with variables like game and root. Other issues with the GUI class. You see that there's lots of hard-coded values in there. We have a size, we have these hard-coded colors. Rows and columns is 8, which, well, for a chess game, of course, that makes sense. Also, if you look at init game, there's a default fence string to create the initial setup of the board. But if you scroll down, there is more, like here, for example, the end screen, you see that there's a fixed value chosen for the sizes. Now, of course, it's fine, you need to pick a value, but it's good to move these things out of the code itself and put them in settings. At least put them as constants at the top of the file so you can easily find them and change them. And probably some of these things you can actually just compute. For example, the placement of the end screen, which is a dialog, you can also compute it based on the position and size of the top window. So you may not need to set a hard-coded value for that at all. Another thing you see in the initializer is that there is some initialization logic here. We're creating a board, like we're creating the chess logic instance, we're setting some colors. Then we have a frame.init, so we're calling the superclass initializer. And then we're still doing more initialization work. I wouldn't do this. I would put the superclass initializer either at the top of the class initializer or at the bottom, so that it's clear in what order things are being initialized, and don't do it halfway like this. Also, don't call frame.init, call super.init, because then the initialization call is going to be less dependent on the particular name of the superclass. Then we have the CommandHandler method that gets a position and then has quite a bit of complicated logic to compare colors of different pieces in the GUI, etc. I don't think this belongs in the GUI. This is game logic, so you should move it probably to the game logic class. There are some GUI elements in it, like we are coloring the squares that the piece can move to, which, by the way, doesn't work when I try to run this, so I'm not sure what is happening exactly. But as you can see in this code, there is like lots of very complicated logic here, like accessing the board and then the piece, position of the piece. So this is extremely hard to read because we're really drilling down deep into the objects. It's much better to put a layer between those very low-level board and pieces and access that layer here instead to determine which fields you should color differently, instead of doing all that work here directly in the CommandHandler method. Also, be careful about what you're storing in a class as an instance variable and what you're storing as a temporary local variable. Here in the endScreen method, let me scroll down, that's here, you create a bunch of GUI elements that actually don't need to be instance variables, like for example, winner label and the retry button. They're already attached to the end window by passing the end window as an argument. So you don't need to store it as an instance variable. And these instance variables are also not used anywhere else in the class. Another thing is that actually the end screen itself, which is a dialog, should probably not be defined in the GUI class at all, but it should be a separate component. And then you can use the component in this GUI class. Another thing is that you are using pretty rough type hints, like here a list, for example, but we have no idea what kind of list, what are the types of elements that are in this list. And this happens in more places in your code. For example, CommandHandler has the same issue. It gets a tuple, but we have no idea what is in the tuple. If you're using type hints in this way, it's kind of useless because as soon as we unpack this tuple, we have an X and a Y, but we have no idea what the type is. And of course, the type system also complains about that. If you use type hints, use them precisely and specify what the types are exactly, because then you get the most benefit out of it. The types are also precise on another level, because in some cases, position is a tuple, and in some cases it's a list, which is really confusing. So pick one. It's either a list or a tuple. It can't be both at the same time. You can even imagine that putting this in a list or a tuple might be overkill. You can just use an X and a Y int value instead. It's just 2 arguments instead of 1. Another thing is that whenever you make a move in the game, then the refresh method is called. When the board is refreshed, then for every position on the board, we're creating a new photo image. So we're loading a file from the disk. We're creating a bunch of new buttons. And these are actually put on top of the old button. So every time you click, it's going to add a new layer of buttons on top of the old ones. And only when you restart the game, all of these GUI elements are being destroyed. And this is extremely inefficient. It also means that if you're playing a longer game with lots and lots of moves, you're going to have lots and lots of buttons and images, which is going to really slow down your application. And there's no need for this. You can simply reuse these buttons, and you can have one image for each of the different types of chess pieces and simply refer to that single image in your GUI code. And that means that for longer games, you won't have that slowdown because you're not creating all these GUI elements all the time. I want to move on to the pieces class. So there is a piece abstract base class. Again, here, same issue with the type hints. Be precise, indicate clearly what a position is exactly, and not just pass a tuple. And that also goes for return types. For example, getMoves will probably return a list of some sort, but we are unable to see what that is exactly if we just look at the abstract base class. And the whole idea of an abstract base class is that you're going to provide an interface, that it provides clarity to the developers what kind of thing they should do when they create a subclass, and now it's not clear. In terms of the overall design, you've made a choice to have a piece superclass and then create subclasses for every different type of piece. So there is a pawn piece subclass, there is a rook, a knight, etc. Every chess piece has its own subclass, and that has some unfortunate consequences. You can see it clearly when we look at the logic. I'll come back to the logic class later. But if you look at the move piece method, which is the main logic, you see that it's filled with these isInstance calls to check whether a piece is of a certain type. So when you look at it from a design perspective, in a chess game, you're really often checking what type of thing another piece is. That's a really common operation. It's really important to identify what these common operations are in your application so that you can make sure that those are going to be really easy to do. And at the moment, they're not easy because we have to call isInstance. We have to directly access the board X and Y value here and then compare it with the class name, which is just really cumbersome. So I think it's really important to refactor this and set it up in such a way that this operation, checking what type another piece is going to be really easy. There's another issue with using subclasses for each of these different pieces, and that happens in the getMoves method that you have. So getMoves computes for every piece what the valid moves are that that piece can take. And there's overlap there because there's only a limited number of moves, a limited number of types of moves that a chess piece can make. So you have like horizontal moves, diagonal moves, and the knight moves, and then maybe a few smaller variations of that, but it's pretty limited. And you can certainly reuse those move groups for each of the different pieces, which currently isn't happening because now you have to write a separate getMoves method for each of the chess pieces, which results in a lot of duplication in the code. And there's other duplication as well because you're using this class and subclass structure. For example, the string dunder method that each piece has looks very similar for each of the pieces. It's simply returning this character if the color is 0, or else it's going to return that color. Of course, there's a different character for each of the chess pieces, but the logic here is always the same. And the same holds for the image. So every piece subclass sets an image that is pieces / and then the name of the piece plus the color plus .png, and that's copied over in each of the pieces. So that means that now if you decide to move the PNG files to another folder, you have to go through all of the classes to fix this code, which is a lot of work. And there are also some other things, like for example, you have a pos instance variable which contains a tuple, but there's also an X and a Y, and actually pos is not used anywhere in the code, so there's no need to store this. Finally, you're using integer values for color. So for example, here you see this, 1 for empty and then 0 for white. and 1 for black. If you use an enumerated type, you don't need this kind of comment because it's going to be clear from the type name. And then pylons, if you're using VS Code, is going to help you point out if you made a mistake in setting the value of this color. So instead of using these integer values, use enumerated values, much easier. And you can also see that in logic.py, which contains the chess logic. So we have a status where we have 1 and 3 and 2, which all means different things. I would use an enumerated value so that it's clear what each value means. You also see that if I scroll down, that you're using the color value to determine whether you should do something, like here if the color equals 0. So this also means, because you don't use an enumerated value, that we have to remember as developers all the time, oh yes, 0 is white and 1 is black. And that's just extra mental space that's not necessary, because you can use an enumerated value and then it's going to be immediately clear from the code. So use these enumerated types more. Also, like I said, for status, which by the way should be lowercase since this is an instance variable and not a constant. Then there's a lot of duplication in this file as well. For example, populate with fen gets a string, a fen string, and then it's going to parse that string and create the board. So that's basically what you see here. There's a really repetitive if-else statement here. The only thing it's basically doing is taking a character and mapping it to a type. But the way you've set it up now is that there's a lot of duplication. And then we have the same thing if I scroll down for the uppercase version, which is the other color. You should definitely set this up differently to reduce some of this duplication. Another thing is that populate with fen is actually a creation method. It creates a board filled with a particular configuration of chess pieces. I don't think this belongs in the logic class because it's creating something, and you should generally separate creating things from using them, so you can also easily test them later on. I'll talk more about that later. And there are other confusing things as well. For example, if I scroll down, you do this in multiple places, is that if I look at the check for check method, you see that we have an X and a Y value. Now I would expect when I see this code that X and Y are indices and that they have the same type. They probably are both integers, right? But actually that's not true. X is an index and Y is a piece. So this is really, really confusing. Don't do that. If you have an X and a Y in code that you're using in this way, they should be the same type and they should have a similar meaning. If it's something else, give it a proper name. So overall, what we see here in logic.py, but you also see it in GUI.py, is that we have all these is instance checks. You're accessing the board directly. These are violations of the so-called law of Demeter. What is the law of Demeter? It's also called the principle of least knowledge. What it basically states is that each unit of code should have the least knowledge possible of other units of code. That increases separation if you do that. And here this is problematic because due to is instance, we need to know about the class and subclass relationship between the different pieces. And because we're directly accessing the board at indices, we also need to know implementation details of how the board is built up. And that's not a good thing, because if you want to refactor things, you want to maybe use a different data structure for the board, then you're going to have to go through all the logic to fix the problems. And that's just going to be a lot of work. So move piece is really filled to the brim with these kind of violations. So at the moment, move piece is impossible to test. It's impossible to refactor. It's just going to be a lot of work. A minor thing that I also noticed is that you're mixing up a snake case like move piece and camel case like populate with fen. Don't do that. Stick to one. And in this case, stick to the Python standard, which is snake case. Another minor thing, so let me scroll down, is the check for mate method that you see here has really deep indentation. So there's a double for loop, there's an if statement, another if statement, yet another for loop, yet another if statement. So this really results in code that's hard to read. What you can do is structure this code differently by using guard clauses, and that really helps with readability. So let's get started by adding these guard clauses. But before I show you how to do that, give this video a like if you are enjoying it so far. It really helps other people find the content as well. For the guard clauses, I'm mainly going to concentrate on this part and not so much on the surrounding for loops. These ones are a bit harder to fix. I'm going to start with this if statement because this if statement results in all of this code being indented an extra level. What you can do to solve this is to swap the condition and then continue. So instead of checking that the color is equal, I'm going to check that the color is not equal, and then I'm going to continue. And now I can take all of this code and de-indent it. So that's already one level of indentation that's gone. Here's an example of something that is already a guard clause. So if it's king and we have moves, then we're going to return false because then it's not checkmate. Now we end up with another if statement. Actually, the else is not needed. We can simply write if, because if this is true, then we're going to return false. So now we have another if statement that we can turn around and turn it into a guard clause. So here we're checking that it's not a king, and then we do this. But what we can do now is, if it's a king, then we're going to continue. And now we can de-indent this logic. And yet another indentation level is gone. Then you can probably take a look at these if statements because there is some overlap in the condition, and potentially rewrite this a little bit so that it's a bit clearer what's happening here exactly. But as you can see, just by switching around the logic a bit, I've removed now 3 levels of indentation. One thing you can also do to really improve this is take this logic, which is basically traversing all the pieces on the board, and build an iterator that supplies all of these pieces, so you don't have this nested for loop anymore. And then probably the logic that's actually here, you might want to move that into a separate method. A second idea for refactoring is related to the pieces. So as I said before, pieces are currently in an inheritance structure with an abstract class with lots of duplication. So what I did is I've created an alternative here. So I don't want to do this full refactoring in the video because it takes way too much time, but I want to show you a bit how I set this up so you get an idea of how to do this differently. So what I did here is I have created a new piece class. Let me just scroll past this. I'll come back to that later, which I turned into a data class. And it's actually way simpler now. It has an X and a Y, so there's no duplicate position being stored anymore. And there are some other attributes as well, such as the color and the piece type. So instead of using subclasses, I've introduced a piece type enumerated value, and that you can see here at the top. So I simply made for each piece in the chess game an enum value. So that's the pawn, the rook, etc., etc. And I also defined a color enum, so that instead of using values like 0 and 1 for the color, we simply have color.white and color.black. And also, instead of having to do isInstance everywhere in the logic, we can now simply access the type instance variable of the piece object and check which type of piece it is, which is way simpler. So another thing I did is to remove some of the duplication, especially for images and string representations, by creating these two methods. So first there's a property that gives us the image, and that's a f-string pieces / and then I'm getting the type and the color.png. And this should actually be color.value. Otherwise this doesn't work correctly, and also type.value. So now I have a single place where I define where the image is located. And this we could even turn into a constant that we define at the top of the file so that you can easily change the path if needed. And then for the string representation, I did something similar. Instead of repeating this logic for each of the subclasses, I made a piece string constant. You can see that I defined this here at the top, where I mapped an enum value to a tuple of the black and the white colors of a particular chess piece. So now all these characters that we saw before were split out over all the different piece subclasses that we have here are now located in a single constant value. So we can also much more easily update them later on. Another thing you can also do if you have a single piece class is that you move some of the logic or some of these convenience methods to the piece class. For example, before we had in our logic class a promote to queen, which takes a piece and then actually turns it into a queen. And here we had to create a new object because of the class and subclass structure. But actually in this version of how the pieces are represented, promoting a piece to a queen is nothing more than changing the type to a different piece type. So what I did is I added here a method, promote to queen, that simply changes the type. So this is going to simplify the logic because the logic doesn't have to know anything about pieces anymore, because the logic can simply call promote to queen on a piece and not worry about how that is exactly being implemented. I'll come back to this file in a minute. What I want to show you as well is an idea for how you could better represent a board. One thing that we saw in the logic file is that there were lots of law of Demeter violations that were accessing directly low-level data in the board, which is not what we want. So here's a suggestion of how you can do this a bit differently. What I did here is I created a new class called board that's going to represent the playing board. And board, what is that? Well, that is a data class that contains a number of pieces, and pieces is a grid. Grid, where does that come from? That's a type that I defined here, which is a dictionary that takes a position and a piece. And position is actually a really simple type. I'll come back to this file later on as well, but that's simply a tuple that takes 2 integers. And what I did here is that pieces is of type grid, that is a field, and I'm using a default factory, which allows you to specify in a data class how a certain object or instance variable should be initialized. And in this case, I'm going to use the function empty board. And that function is here. This function returns a grid. And what it does, it simply goes through a range of X and Y values and then creates a number of pieces. And then it returns the grid so that it's stored here. Then I'll come back to this method in a bit. Then I've added a few convenience methods. So here, for example, I have a method to place a piece on the board in a certain XY position. So now I can, in my logic, call the place method. And I don't have to know anything about how the board is represented internally, because that's covered up by this method. And same here. This returns a piece at a certain position. And they added more. So here, for example, I have a check whether some position on the board is empty. That simply returns a Boolean type. I have some import issues here, by the way, because I copied these files over from my work in progress repository. So that's why you see these red underlines from time to time. Another convenience method they added is find the king. So we pass a color because we want to know whether we should look for the white or the black king. And then simply I'm looking through the pieces to locate the king. So also here I'm protecting the logic layer from the low-level data that's inside the board. Now the next step, when we go back to the logic, is that we have in the logic a populate with fen method. I already mentioned that I didn't think this was a good idea because you need to separate creation logic, like what we're seeing here, from using the object. So I just think this shouldn't be part of the logic class. But now that we have a board and a piece class, we can actually move the fen processing to those classes where it makes way more sense. So what I did in this example is that if you look at the board class, I added a static method that's called fromFen that takes a fen string and that returns a board. So this is in principle a kind of initializer that you can use to create a board from a fen string, which is really useful. So what happens here is that I first create a board. So this calls actually the initializer that's generated by the data class and initializes the pieces. And then I took the code that was here, basically these first few lines, and I put them here in this static method. And then I did something different to solve this issue with all of these if-else statements. Because here we have to do a mapping from these characters to actual types. So what I did in my pieces file is that I created a fen map, which takes these characters and simply maps them to a piece type so that I know that if I see this character, what kind of piece am I supposed to create? That means that the whole creation logic now is also way simpler. So what I do is I simply create these pieces here, but you see that I now also have a piece.fromFen. So I don't just have a board.fromFen, which creates it on the board level. But if you look at my piece class, I also have a static method fromFen that gets an X and a Y value and a fen string. First, I determine what the color is. So if it's an uppercase letter, it's the white color, else it's the black color. And then I return a new piece where I pass that color, and then the type is going to be the type that I get from the fen map that I defined here. So in this way, creation logic is where it belongs, and it's completely moved out of the logic. And also I removed all of those if-else statements, but I simply use a map here to make sure that I map the right fen character to the piece that corresponds to it. Separating creation from use is a really important principle, and you can apply it in lots of different cases. A design pattern that's built on this principle is Abstract Factory. If you want to learn more about Abstract Factory, I've put a link to a video where I dive into the details at the top. A final thing that I want to show you today is how to deal with these getMoves methods that are part of each of these subclasses. In my version, there no longer are piece subclasses, there is a single class. So how do we do that? What I did in the board file is that I created a dictionary called moveLists. And that maps a piece type to a valid move calculator. And that's a function, it's a callable that gets a board and a position, and that returns a list of positions. I did this here for only one type of chess piece, but you can create functions for each of the different types. And I've put them in a file called moves.py. So I mostly copied over the getValidMoves from the rook class in the original code, and I passed the board and the X and the Y, but I've cleaned up the types a bit, and now I also use these convenience methods that I added to the board class. So as a result, the logic is now a lot easier to read. For example, here is just a check if the board is empty, or we just check whether two pieces are of the same color. Now it's still kind of complicated. I still think you can improve this more. I'll talk about that in a minute as well, but at least there is already a level of separation between the lower level board class and getting the valid moves for a particular chess piece. One final thing that I did here is introduce some abstraction. So in essence, what getValidMoves does is that it only uses the empty and piece methods of the board. So I created a protocol class here, a board protocol class that has these two methods. And that means I don't need to actually import the board here. I can simply use the protocol class, and this is going to define what kind of methods the board object is going to have. I want to end this video with a few points. So first, there's still a lot of duplication in this getValidMoves function, and if we do this for each of the pieces, we're going to end up with lots and lots of code. Probably it's better to split this up more and think about classes of moves that pieces can take, like horizontal moves or diagonal moves. And then instead of computing those moves directly in a getMove function for a particular piece, you could have functions that compute this for a group of moves. So you could have a function that computes valid diagonal moves. You could have a function to compute valid horizontal moves. And you make like a couple of those. And then for each piece, you basically only have to define the classes of moves that that piece can take. And that really simplifies things a lot, because then you've removed all this duplication and put it into classes of movements that these pieces can make. And you can even create another dictionary that maps each piece type to the valid move classes that it can follow. And then you can define one function that goes through each of these classes, adds them all up, and returns that as the total list, which removes most of the duplication. Another thing is that I didn't really have time today to move deeper into the logic class. In particular, this move piece method is way too long. I do think that by moving to a single piece class and by creating a board class that separates a bit the low-level data structure from the rest of the logic, you can already simplify this method a lot. For example, this if statement, you can now do it in a much shorter way, but still there's probably a lot of room for improvement in how the logic is set up and whether you can split up the logic a bit more. If you have any specific suggestions for improving complicated logic like this, let me know in the comments. So I hope you enjoyed this roast and the light refactoring. Thanks again to Adam for supplying the code for this one. Give this video a like, subscribe to the channel if you want to learn more about software design and development. If you enjoyed this roast, you might also like this one, where I refactor a rock, paper, scissors, lizard, Spock, Hellbrand game. Okay, no Hellbrand. Anyway, thanks for watching, take care, and see you soon.